Hi folks, Mrs. Gates here. Welcome to Science. Today our topic is generating electrical energy. We will be talking about how we get that electricity that comes to your house every day. Before we get into our topic, however, let's review quickly what's due this week. There are 3 things for this week. A reading called the solar source. There's no fuel like an old fuel. You will need to take a quiz on this presentation and the energy transfer lab that you started on Tuesday. We started our unit discussing that energy can take various forms. We looked at 8 specific types of energies in our discussion. Mechanical energy, or energy of an object in motion. Sometimes this is called kinetic energy. Radiant or light energy. Energy of sound. Gravitational energy, which is the energy of position when something has a height. Chemical energy, which is the energy stored in between the bonds of molecules and atoms. Warm objects have heat energy. Electrons or other charges moving gives us electrical energy. And nuclear energy that is stored within the nucleus of an atom. The first law of thermodynamics tells us that energy is always conserved. It can be transferred between objects or in and out of a system, but energy is never created or destroyed in the universe. Let's consider a candle burning. As the candle burns, chemical potential energy that is stored in between the molecules of the wax is converted into light energy and heat energy. The energy changes forms and moves from the wax into the surrounding air as it heats and gives us light, but none of the energy is created or destroyed. Let's consider the energy changes that happen in a typical automobile engine. The energy starts as chemical energy stored in the gasoline in your gas tank. As it burns, about 25% of that energy goes into useful things, like pushing your car forward, running your radio, turning on your headlights, or helping you open the windows. Much of that energy is lost due to friction, cooling the engine, or simply as exhaust. But all of the energy that's released as the gasoline burns is still present in some form. The second law of thermodynamics tells us that no process is 100% efficient. Said another way, anytime there is an energy transfer, some energy is lost due to heat. If we consider an energy transfer process, when we talk about efficiency, we mean how much of the total input energy became our useful output. In order to calculate something's percent efficiency, we take the useful output energy divided by the total input energy and then multiply by 100. If you have ever touched a light bulb that has been on for a while, you notice that in addition to producing light, a light bulb produces a good amount of heat. The heat isn't usually why we have the light bulb on. So when we consider the efficiency of a light bulb, we look at how much of the input energy is released as light. If we compare some common types of light bulbs, we see that the old-fashioned incandescent bulbs, those are the ones that have a hot filament inside that glows, only give about 8% of their energy as light. 92% of the input energy becomes heat. Halogen bulbs do a little bit better, but compact fluorescent bulbs and LED bulbs give between 30 and 40% of their energy as light, making them much more efficient than an old-fashioned incandescent light bulb. In your energy transfer lab this week, you investigated transferring energy from a burner in order to heat water. If we consider the energy transfer taking place there, we find that some of the energy released by the burner comes out as light. Some of it heats the air, and some of it is used to heat the water. When you calculated the efficiency of your process, you said the useful energy was the amount of heat that went into the water. The heat that went into the air or the glass or the light that came out of the burner was considered waste energy in this scenario. These forms of energy transformations, and efficiency are not new. Our new topic for today is looking at what sort of energy transformations happen in order to give us the electrical energy that we rely on. The first question we have to answer is, what do we mean by electrical energy? Electrical energy is the energy of moving electrical charges. This is usually electrons moving in an organized way through some sort of conducting material, like a wire. So, how do we get those electrons to move? There are three main ways we use to generate electrical currents. In batteries, we use a chemical reaction. In solar panels, we use the photoelectric effect. And in most of the things you think of as electrical generators, we use a process called electromagnetic induction. Let's look at those three processes in a little bit more detail. If we examine how a chemical reaction can make electricity, we usually think about batteries. They are taking chemical energy and turning it directly into electrical energy. They do this through a process called an oxidation reduction reaction. There are a lot of details here, but in essence, you have two different metals in what we call an electrolyte, which is usually a liquid. That liquid allows the reaction to occur, and in the reaction, electrons are transferred from one metal to the other metal. This gives one of the metals a positive charge and one of the metals a negative charge. Once one metal has a positive charge and the other has a negative charge, if you connect them with a wire, you will get a flow of electrons as the electrons move towards the positive charge. The second method for generating electrical energy is called the photoelectric effect. This is what you see in a photovoltaic solar panel. Light energy is directly converted into electrical energy. If we look at the process in a little more detail, we see a light particle or a photon coming into this atom. When it hits an electron, that electron is bounced out of the atom. When the light comes in and bounces electrons out, they are directed towards one contact that becomes negative with the extra electrons. When a wire is connected, these electrons then flow through the wire towards the positive end of the metal, thus creating a current and electrical energy. The third way to generate electricity is through a process called electromagnetic induction. This is what happens whenever you have a turbine. The turbine converts kinetic energy directly into electrical energy. It turns out that whenever a magnet is moved relative to a coil of wire, a current is generated in that coil of wire. This can be done by either rotating a magnet, like you see here, or by rotating the wire in a magnetic field. Most of the electricity that we use is generated by some sort of spinning coil of wire. It turns out there are a lot of different ways to spin that coil of wire. Whenever we have a steam-powered turbine, we have some source of heat that boils water into steam. That steam moves through a turbine, pushing the rotor around. This is what spins the coil inside of the magnetic field and generates the electricity. Steam-powered turbines can be powered by many sources of fuel: coal, oil, nuclear fuel, geothermal power. But in essence, they are all spinning a coil in a magnetic field. Water-powered turbines and wind-powered turbines are also just methods of rotating a coil of wire in a magnetic field, thereby producing electromagnetic induction. The last topic we will discuss is renewable versus non-renewable energy sources. Renewable energy is energy that comes from sources that are naturally replenished on a human timescale. These sources of energy will never run out because they are constantly renewed. These are things like wind, sun, and flowing water. Let's take a moment and look at the types of renewable energy we have in Wisconsin and around our country. Biofuel is any fuel that is derived directly from plant material. These fuels are often mixed with other existing fuels, like gasoline or diesel fuel. In the United States, most biofuel comes from corn in the form of ethanol and is then added to gasoline. Wisconsin produces over 500 million gallons of ethanol per year, making us the ninth largest ethanol producer in America. Wind power generates energy as wind turns a turbine that causes a coil of wire to spin in a magnetic field and thereby generates electricity. As of 2016, Wisconsin generated 2.4% of its electricity from wind. We have over 14 wind farms in our state. Hydroelectric power derives its power from moving water sources. As the water flows from a higher level to a lower level, it turns a turbine, which turns a coil of wire in a magnetic field, thereby generating electricity. We have a hydroelectric power plant in Wausau, Wisconsin. It generates about 5 megawatts of power. There are 25 hydroelectric dams on the Wisconsin River, making it one of the most productive rivers in the country. We already talked a bit about the photoelectric effect and how a photovoltaic cell works. But solar power actually comes in two different forms. The first is solar thermal power, used to heat water and cook. Photovoltaic power is used to produce electricity. Let's look at solar thermal power first. Solar thermal power simply uses the sun's ability to transform light energy into heat energy to heat water. Cool water is pumped in through an inlet. It then travels through coiled water pipes over a dark surface. As it travels, the dark surface absorbs heat and heats the water. The hot water is then pumped out of the outlet. This can be used to heat other things. Solar cooking can also be done with reflective surfaces and insulated containers. The benefits here are that solar cooking consumes no fuel or wood and therefore generates no air pollution or greenhouse gases. It also eliminates fire dangers. The second type of solar power is photovoltaic cells. We talked about this as one of the three ways to generate electrical energy. And in essence, sunlight causes electrons to be released from the photovoltaic cell. This causes a current to be able to flow. The largest solar power plant in Wisconsin is the Rock River Solar Plant near Beloit. It generates 2.3 megawatts of power. Over 2,000 homes in Wisconsin are powered by solar power. The last form of renewable energy that we will talk about is geothermal power. Since we do not have very many active fault lines in Wisconsin, we are not a great source of geothermal power. Geothermal power works when the Earth's core heat is used to heat water that turns into steam. The steam then turns a turbine, which turns a coil of wire in a magnetic field and generates electricity. Here is a map of the United States showing where we find the most geothermal power. Notice that these regions tend to be the most geologically active, having fault lines and earthquakes that can also cause heat vents that allow the Earth's core heat to be nearer to the surface. The types of renewable energy sources that we have talked about here are solar energy, biomass energy, wind energy, hydroelectric power, and geothermal energy. The world also uses a great amount of non-renewable energy sources to generate electricity. These are primarily fossil fuels and nuclear energy. All of these forms of energy use some form of fuel that heats water. This hot water turns into steam. The steam turns a turbine, which rotates a coil of wire in a magnetic field and generates electricity. Whether we are burning coal or natural gas or using nuclear fission in order to heat water, the process is the same once we have hot water. If we consider the entire United States energy consumption by source, we can look at some data here from 2017. This graph includes transportation, making petroleum the largest sector of our energy consumption. It's followed closely by natural gas, coal, and nuclear electric power. In total, renewable energy sources only made up 11% of the United States consumption. Shown here, the largest portion of the renewable energy was hydroelectric, followed closely by biofuels. Most of the power in this area comes from the Weston Power Plant located near Cedar Creek. Weston Power Plant burns both gas and coal and produces 910 megawatts of power. If you recall, Wausau's hydroelectric power plant only produces 5 megawatts of power. The topics we have covered in today's presentation were the first and second laws of thermodynamics, including the types of energies and what we mean by efficiency and how it is calculated. We talked about 3 ways to generate electrical energy: through chemical reactions, the photoelectric effect, or electromagnetic induction. And we discussed renewable versus non-renewable energy sources, both how they work and where they are found around our state and our country. Remember that this week your assignments are to take a quiz on this presentation, to complete your reading, Solar Source, There's No Fuel Like an Old Fuel, and to submit your energy transfer lab. Have a great week.